We are going to solve a Leetcode question which is called as count the number of computer unlocking permutations. In this question, you are given in complexity array where each index represents the complexity involved while unlocking a computer. In this question, few things are already given. First is that the zeroth index computer is already unlocked, and in order to unlock any other computer, there are few conditions that needs to be met. First is that if we are trying to unlock an ith computer, for that we need to find a jth index complexity which where j should be less than I, and the complexity of open like unlocking the computer at jth index should be also less than that the value of the computer that you are trying to unlock currently, which is more like, let's take an example and try to understand. So in this is our example where we have 1, 2 and 3. What will happen is that 1 is already unlocked. One PC is already unlocked, which is 0th index PC, which is already unlocked. When we try to unlock PC number which has complexity 2 at index 1, what will happen is that according to condition we need to find an PC which is already unlocked, which is this one. It is already unlocked, so this will become jth index will be this, and this will be ith index, and the value is 1, like complexity of unlocking the jth PC is 1, which is strictly less than the value that we are trying to unlock. This is the main thing that we need to keep in mind. Now let us understand how we can solve this easily. Let's take an interesting test case and try to understand how we should approach this question. Here what will happen is that the first third complexity PC will be unlocked, right? The first zeroth index will be unlocked. Let's write also 0, 1, 2, 3, 4 and 5. Yeah, that's how. So zeroth PC is already unlocked. When we try to unlock first index PC, we will not able to unlock it because it's equals to the already unlocked PC. Whereas we can unlock the third index PC, fourth index PC or fifth index PC, because when we try to unlock them, we have value j, which is 3, which is less than the current value that we are trying to unlock. So in this case, what will happen is that we will not able to unlock 1 and 2 index PC because the value is equals to the minimum amount. So from here, what we can derive is that if any value in our complexity is less than or equals to the zeroth index of the unlocked, like zeroth index will be always unlocked, right? If any value in a complexity like array is less than or equals to then the first element, like zeroth index element value, then we will for sure say that we are not able to unlock every PC in this like in this array, and we will simply return 0. If we remove that case, what will happen is that, let's see what will happen if we have 1 here. If we have 1 here, what will happen is that 1 is the minimum thing. It satisfies, like we are able to unlock every PC. Now let's try to find out all the permutation. From the given question, we know that first place is always reserved, right? First place will be always reserved, which will be taken by the zeroth index itself. Zeroth index is the first place. Now we have total 4 place left. We have 5 place left, right? From 1 to 5th index, we have 5 place left. When we try to place like in the second place, how many permutations we have? We have total 5 combinations here, right? We have 5 elements left, so we have 5 combination. We can like place any 5 like any element for out of 5 elements, right? After that, what will happen is that when we try to place the second index element, we have total 4 combinations which is possible, because if we like allocate 2 elements in first second place, only 4 places are, only 4 elements are left which can be placed in this exact place. When we try to place an element in our third index, we will now have only three possibilities, like only three values can be interchangeably like put there. When we try to have a value which we want to place in fourth index, we will have only two possibilities. And when we try to like add value to the sixth index, we will only have one possibility. From this, what we can derive is that we have five possibility here. We will multiply it with 4, we will multiply it by 3, we will multiply it by 2, and we will multiply it by 1. From this, what you can see is that it's following factorial of n minus 1. If the size of our array is n, first element is already taken, we will do 1 minus and we will find factorial. This thing will be applicable for every solution. Now let's see the code walkthrough. What we are going to do is that we are simply checking if any element is less than or equals to the minimum value when we start from first index and go to the size of the array. If we find any element, we will simply return 0, else we will find a factorial of size minus 1. While finding the factorial, we need to also, for every iteration, we need to mod the value because it's given in question that answer can be large and we need to return the modulo 10 to the power 9 plus 7.